All right, hello everyone. I'd like to welcome you to the eBee Vision online demonstration. The purpose of this is going to just provide you some great information and do a good walkthrough of some of the capabilities and how this system can potentially serve some of the use cases for your customers or interested parties. And it's actually going to provide some information to our VARs and distributors as well, how you can have those conversations and some be armed with some of the ammunition you need to kind of have technical discussions so we can get this platform widely integrated into the defense and public safety vertical. I'd like to also thank the marketing team too for putting this together. So thank you, Vincent and Anna, I appreciate it. So a little bit about my background. I'm the head of defense currently for AgEagle Aerial Systems. I started last April. I served 21 years in the United States Army, and the last position I held for about the last 5 years was the ISR and UAS program manager of the Special Forces Group. You'll see Jean-Christophe in some of the video content later. He's the head of GNC and aerodynamics and was instrumental in developing the platform. So some administrative notes before we begin. So all of the questions will be addressed in the Q&A session that will follow at the end of the webinar. And additionally to that, you're going to receive PDF copies of all the slides and a webinar recording in 24 hours, then provided to the email that you registered for this session with. So what do we do? AgEagle. So we provide full stack drone solutions for customers worldwide in the public safety, defense, government, energy, construction, and agricultural verticals. How we do it. So our first entry to the defense and public safety vertical was through our ATAK platform, providing topographical mapping at the point of friction for tactical formations and public safety oriented environments. We also deliver sensors that are industry leading for MSI production. And we also offer software for flight control and fleet management. So our eMotion software that's available on our eBee-TAK and eBee-X series of drones is industry leading for interoperability and ease of use. And then our fleet management through Measure. So real time. So here we're just talking about the eBee Vision. So what is the eBee Vision? Well, it's our newest entry in the AgEagle line. It's going to provide real-time situational awareness, right? So what is real-time situational awareness? It's basically intelligence data that we want collected in real time at the closest point of friction, right? So it enables operators, tactical infantry formations or cavalry units, and even public safety, like law enforcement, search and rescue entities. It gives them, a good picture of what's happening in time and space, and environments that they might not be able to potentially go to themselves, and it just gives them an additional capability. Be able to monitor situations, collect intelligence, and then share that rapidly across their formations or units. So how we got here. So in 2009, we started with the swinglet cam. It was literally basically a piece of styrofoam that could fly with kind of a camera mounted to it, right? So fast forward, 12 years, and the latest entry into this sector with the eBee Vision. It's a lightweight, rugged, portable, quick setup, one operator, ease of use, cyber secure, NDAA-compliant platform, right? AgEagle really focuses on those core verticals that you'll see there, the lightweight, rugged stuff, and safety oriented by keeping it light. We also focus heavily on ease of use, 3-minute setup by one operator. We want to get the platform in the sky, collecting intelligence quickly. We don't want to have the operators or public safety personnel dealing with a complicated process of employment. We want to be able to make sure that the system is absolutely 100% ease of use. And if something does go wrong while it's flying, it was designed for safety in mind, so nothing really is going to happen to anybody on the ground potentially as well. So here's some of the core technical characteristics of the eBee Vision. So it delivers real-time situational awareness, both in RGB and thermal, for the ISR mission set. It serves the needs of special operations, conventional military units, public safety, and government professionals. So it's extremely lightweight. It's about 3.5 pounds. Once again, reinforcing the NDAA compliance. eBee Vision features live HD video at a flight time of 90 minutes, and it can provide wireless coverage up to 12 miles or 20 kilometers. Once again, can be employed in just 3 minutes and operated by a single user. In the next slides, we're going to talk about some of the technical innovations of the eBee Vision, the ground control station interface, the ISR capabilities in GNSS-denied environments, high accuracy imagery, and some of the other technical features like autopilot takeoff and landings. So the ground control station interface, once again, you're going to be able to monitor the RGB and thermal views on this. You're going to simultaneously capture, view, and record imagery. So not only will you be able to see the imagery as it's being conducted or being streamed, you're going to be able to share that and capture photos of specific areas of interest while you're flying. So during its development, the UAS received input and a lot of positive feedback, both from US and European special forces in its development. So that's one thing that a small company can really do, is that we, value the end user feedback, and we can integrate that potentially a lot quicker than some of our larger competitors. I was a former end user myself and had some of the, inputs of some of the features and things like that into the GCS itself. A lot of with our defense-oriented partners in the US as well, and incorporating their feedback that they provided through its development. This thing was designed to be extremely easy to use. So the entire left side is going to be all of the aircraft inputs itself, and the entire right side will be anything that you need to do to adjust the sensor while in flight. You can plan custom flight plans. You can do kind of, point out and back type missions. You can set up boxes around NAIs. Another thing that's great about this too is it has lat-long integration and MGRS. So you can basically define points of interest that you already have preset for a mission or a public safety use case as well. So if you have known areas where potentially search and rescue things happen, all of these mission sets can kind of be pre-planned and loaded and ready to go. You don't really have to think about it. You can kind of just use this as your planning tool. And potentially, if you have multiple across your formation, you can also share and connect while in flight to other ground control stations. So that's a brief overview. So what you're going to see now is Jean-Christophe. He's going to go through a very good demonstration of kind of all of the things, how to set up the eBee flight modes, things like that. And then, please capture some of your questions for the Q&A session later as we talk through it.
Hello, this is JC from AgEagle, and today we're gonna fly with the eBee Vision. But first thing first, let's unpack. So first, I remove the wing compartment. Let's put them here, and now we just open the main compartment where the drone is. So I always start with the radio. So today we are not going to go far, so we'll go with a small range antennas. So always put the antennas before turning on the radio. Let's do the other one. Okay. And now we just put the battery with the twist lock mechanism. Make sure it's secure here with the secure pin, and we can turn it on. We get the red LED, and it can goes on for a full day with one battery. So it's probably gonna hold for a while. Now let's take out the eBee Vision. We just need to open the battery cover, take one battery. So just put the lid up, and then just slide the battery in, and then secure it with the handle. And now we can close it, and with a long press we can turn on the drone. Now we can focus on the rest, so let's turn the GCS on. Okay, and now we have time to take out the wings. So to plug the wings, it's extremely easy. You just need to align them and push, and that's it. And the only thing we need to make sure is that nothing is preventing the control surfaces from moving. So now we can just let the drone sit next to us and plug the radio into the GCS. So it's just sliding it in. And here we can see on the screen that we have the double arrows. That means that everything is plugged correctly. So now I'm just going to launch the app. Okay, so now as we can see, the LED is green, so we are ready to take off. So if I just press fly, here we have the default flight plan, and we could go. For today, I've prepared the flight plan so we don't fly over people's house. So let's do this instead. So I just go in plan, and here I can load my flight plan. And just selecting it, press open. And now we have our 5 waypoint flight plan. And we can check the altitude of every waypoint. And we also have 3 points of interest that I have put on the map that we can check later on. So before we go, we should check the setting and make sure that everything is correct. So here in the interface, we could change the units, but it's not what we are interested in today. So let's check the flight. So here we use AMSL altitude, which means the drone will keep a constant altitude at all time, which is better if you want to avoid altitude changes, which mean more noise. So like this, it's stealthier. Then we'll have the loop flight plan, which I like, and that the rest of the options are okay. And now if we go into the safety, we can see we have a 3 kilometer radius, 750 meter altitude. The most important setting would be that the altitude referential for the return to home is AED, so which means the drone will use the elevation data to go home and will keep all the safety on. But we could, by a single press, turn them on or off if we want to. So now let's go back into to our flight plan. We can check the elevation by doing this. So now we see the ground is approximately at 600 meters. We are going to operate at 720. So it's legal. Here we can see the ceiling is maybe a bit low. So let's add, we've had 30 meters more. So now we're safe and we can go. So we just press play here. And now we are on the flight menu and we are ready for takeoff. So let's take off. For the takeoff, the first thing is just check the wind direction. So you just do like this. So the wind is coming here. So I'm going to launch in that direction. So I just put my back against the launch direction, hold my drone like this, and perform the shake. So here I make sure the control surfaces are moving. The gimbal is calibrating. And once the calibration is over, I'm ready for takeoff. So now we did take off and the drone is just on hold above us, waiting for us to tell it what to do. So if we look at the screen, we see what we call the map view. And if I zoom, we can see here the eBee vision performing the hold pattern. So let's take a few minutes to go through the interface. So the map view is really meant to get an overall view of the mission. And generally, when you are operated, you should not use it too much. And as we will see, we put a lot of effort, so you can do everything from the video view. But today, we'll probably switch a lot so we can get a better understanding of what's happening. So let's start with the upper part, which we call the telemetry ribbon. In green, we have the information that is related to the battery levels, the link quality, and also the number of satellites that we see. Then in blue, we have all the information related to the drone itself. So we have the coordinate of the drone, the azimuth, the distance between the drone and myself, the 2 altitudes that we may use, the wind speed, and the ground speed. And then on the side, we have in yellow everything that is related to the target. So currently nothing is displayed because the gimbal is not deployed. That also explains why we get a black screen for the video. And the last part is the flight time and also the local time. Another important point is on the everything has been thought so that all the camera function are on the right side, and all the drone function are on the left side. And like this, you can use this to find the function wherever they are. The final and probably most important information is what we see at the bottom of the screen, which we call the status bar. So here it's telling me my eBee vision is on hold and that my gimbal is retracted. So now let's start the mission and let's go through the different functions together. So here I will remove the dead man switch. Okay, and now I'm good to go. So with this button, as you can see, I can circle between the different waypoints. It becomes white. So we go waypoint 1, activate go. And now my eBee vision is in flight plan and the gimbal is being deployed. So from this, we can check the altitude by just pressing the secondary drone control joystick. We see that we are now at 120 meter altitude, and we will stay at this altitude for as long as the flight plan is going. And now we switch to the video view. So now what we see is the RGB camera. So I can use my right joystick to move it around. And as we can see, the gimbal, it's currently moving with the drone. This is what we call unlocked mode. So we can see it in the status bar. And if I just press the hold button here on the right side, we can lock. And now if we zoom on this block, we see that it's now always pointing at this intersection. And then we can go back. And if we press again, we can unlock, and it's now moving again freely, which is extremely useful to get familiar with the environment and get to know the surroundings of the mission. Another thing that we can do during the flight plan is check the various locations that I have marked. So here we'll switch back to the view, map view, and you can see I've marked 3 points of interest. The closest one would be the point 3. So let's select it. So as for the waypoint, this time I use my right hand. You can see I can cycle between the POIs. So now we select 3, we activate it, and now if we go back into the video view, we can see that the gimbal is pointing at the POI 3. So here we can zoom on the building, and we can see that the camera switch will occur around 5 times zoom. Now we are just on the teleobjective. So here we get a nice footage, and if we zoom completely, we can see the level of details that we get. Here, if we look at the right upper right corner, we see at around 200 meters from the parking space, getting further away, and this is full zoom. So now let's zoom out. We can also switch POI. So let's check the second location here in the forest. And now we'll use the thermal camera. So I press the thermal cycling button with my right hand again. And here we now have the thermal image of this small lake. If we zoom in, let's see if we find something interesting today. So not much to be seen, unfortunately. So let's zoom out. So here, this is currently the whiteout. We also have the blackout setting. And let's unlock and try to see. We can look below us on the forest. So if we zoom in, we see that we could easily spot if there are some people or animals here inside the forest. And again, at any time, I can just lock, and the gimbal will maintain in sight what we are filming. And if I press it again, we'll go, and here we are back on RGB, and as we can see, we are still locked. I unlock, fully unzoom, and we are back on our original mission. Last important stuff that we could do during the flight plan is to retract the payload. So I just, again, with a single press, we are retracting, and we are now in what we called the transit mode. So during the transit mode, the payload is up inside the drone body, so we get low stabilization as it's mostly locked into the drone, but like this we maintain a certain amount of visibility of what's happening below us, and we reduce drag, so that will be extremely useful if you have to fly a long distance. You can do this and gain some precious flight time. And again, if I just by a single press, we will deploy the gimbal again, and we'll see it's going to come back, and now we are deployed and unlock again. Now what we are going to do is we are going to use scooting mode, which is again accessed by a single press on the right hand, and here we'll try to follow this car. So as we can see, I just need to follow it with my joystick, and the eBee vision will follow it. Now we see this car is pretty fast, so if I press the fast mode on the drone side, which is left side, we can see now it's fast mode. If we look at the ground speed, we are now going full speed, and like this I can keep track with this guy even though it's going quite fast. And like this we could go for a long time and follow him. So let's stop before we go over the village. But you get the idea. The scooting mode makes it extremely easy to follow a car. Let's try to focus on this one. So again here, what we need to do is just follow the car with the joystick, and the eBee vision will do the rest, and it will just follow the road and go wherever I'm looking at. If we go into the map view, let's point at something. So here, if I'm pointing at this road intersection, okay? If we go into the map view, now we see that we have a circle. So this is where the eBee vision is going to go, and it's going to circle here. So it's extremely easy to use this feature if you need to go somewhere or just follow a moving target. That's probably your best choice. So that would be the basic feature for the scooting mode. Another cool trick that we can do in scooting is I've marked a few locations on the map. So if we see the POI 1, let's say I want to go here. So again, I circle between the POI, I activate it, and now we see that the eBee vision is going to fly and make a circle around this location. So ideally, you would do this without going into the map view, but for 2 days, we'll go and make a few changes, so it's easier to get a feeling on what's happening. So now we are going to take picture of this building. So first, I switch into the picture mode, which you can see here on the bottom of the screen. And now with my finger, I will just trigger some picture of this building. So we'll try to make a few photos. So here we can see we are 250 meters from the building, which is probably so far so they will never hear us. And by using the scooting, we can make a 360 turn, and later on we could use this picture to put them in an app like Farsight and get a 3D reconstruction, which can be very useful to get a fast mapping information. Also one another extremely useful feature is the gallery button. So here on the upper right corner you can see the gallery button. So if I click here, we can see the last picture I've taken at full resolution. So if I zoom in, I can really check the quality of my image. And as you can see, we also have the GPS time and the coordinate of the image. And like this, I can make sure that the picture I've taken are good enough. Let's go back to the map view. So when we are in scouting mode, there are a few advanced features that we can use. The first one is we can adjust the distance between the target and us with what we call the distance joystick, which is on the drone side. So here, as you can see on the map, I can choose to make the circle bigger or smaller. So like this, I can adjust the distance to my target. I can also change the direction. So now we are blinded by the trees. So if I just want to turn in the opposite direction, I go on the side with the secondary drone control joystick. And we can see on the map, the eBee vision is going to make a half turn. And like this, we avoid spending too much time behind trees and we can maintain the visibility on the building. So let's switch back to the video view. So here I've triggered it a bit late, but we'll do it again to get a nice demo. And we'll use this time, this second passage to take more pictures of the building. Okay, so now we're good. Let's take a picture. Another thing we can do is we can use the secondary drone control joystick to check the altitude, but also to change it. If I press it up or down, I can reduce or increase the altitude of 20 meters. This is always available in all the flight modes, and it's extremely useful if you want to change to get closer or further from what you are filming. So let's wait until we reach the trees at the beginning of the forest. So now, as we can see, I'm going to be blinded by the trees again. So I just press the secondary drone control joystick on the side, and we will see the eBee vision will perform a half turn. Okay, so now it's happening. And now we are going the other way around, and like this, we can maintain the building inside forever, which is extremely useful. So it's one cool trick we can do with the scouting. So now that we've done some scouting, let's use the secondary main mode, which would be the observe mode. So here, again, with a single press, we can see on the status bar that we are now in observe mode. And if we go into the map view, we see that the map is now showing the observation waypoint and the square what the eBee vision will operate to point at the POI one. So observe mode, it's meant to look at an object from a distance without getting too close. So now the eBee vision will perform some circles inside the area that is displayed as a square here to give me maximum visibility of this building without circling it. Here we have some people walking around, which here we can see a demonstration of the zoom capacities. So this is full zoom, and as we can see, we are around 700 meters from them. So that gives a good idea of what we can see. So let's unzoom and focus on our building again. So we are pointing on the building one. Here we get some obstruction. It's because we are on the wide angle camera. So we can see the wings and the body, but as soon as we zoom and we go on the teleobjective, we'll see that we get a nice footage and we don't see the wings anymore. So here we are a bit far away from the building. we get the forest, so we probably want to change. So again, let's switch to the map. So here something interesting has happened. As you can see, the flight space has changed. This is because the eBee vision, it's optimizing the trajectory based on wind. Since wind is higher, it now switch to this shape instead of the previous one to give me a good visibility. I can again use the secondary drone control joystick to do some advanced tricks. So here, let's say we want to see the other side of the building. I can just rotate my trajectory. Here you can see that the eBee vision did adjust the flight path based on the new observation condition. And now we get a nice view of the building. So let's go here in video mode and press record. So now we are recording the building. We can zoom out, zoom in. On the video, we also can adjust the contrast with the image setting, so it can be brighter or just a bit darker. Okay, so like this you can adjust as you want. We can switch to the thermal view. So here we can see the people walking by. Okay, so this is the distance. It's almost, we can see 700 meters, and we can easily spot people on the road. So that shows the capability of the eBee vision. So let's go back to the RGB camera. So in Observe, I can also adjust the distance to my target. So like this, we can see I can go further or closer to my target. And you see, as I move the observation point, the trajectory is being adjusted by the eBee vision. Another stuff we can do is we can switch POI. So let's check the location too. We can see that nothing is happening at the lake. Let's go back to check the main building. So we are not just behind the wing, but if we wait, we'll see. So we can switch. We can easily switch from the building to the small lake with a single click. So we can observe both locations at the same time, which is extremely useful. So let's unzoom completely. And then now we've seen what we can do in Observe. We can also just use our finger on the map to move the observation waypoint. And that's also convenient. So now we've covered the Observe mode. We can activate the flight plan again by just pressing Go. And the eBee vision is now going to the waypoint 1. Let's unlock the gimbal and we'll go on the flight path. So the first flight mode that we did not test today is the manual mode. So here I can take manual control of my eBee vision. It can be useful if I want to navigate by sight or if I get GNSS jammed. So if I lose my GNSS, I can still fly my eBee vision in manual mode. So to do this, I just use my left hand. So we can, on the drone side, I press manual. Now we can see the eBee vision is flying in manual mode and the gimbal is facing forward. So this is used so the pilot does not get confused. So it's always looking further. And here I use this time the drone control joystick to just move around. So it's extremely easy. So I can just turn. We can also go up or down. So now we are going down so that we see the nose a bit. And it's extremely simply. So we could use this to just navigate and go somewhere. If we go into the thermal view, it's extremely useful to just look around and find some points of interest on the map. So the main difference between the manual mode and the scouting mode in manual mode, the camera is looking forward and we are piloting the drone. If we go in scooting mode, we are actually piloting with the camera, so it happens with the right hand. And when the drone reaches the place we are looking at, it will make a circle. So here, if we look on the map, we know the eBee will circle the building. If we do this in manual mode, we'll just end up in a straight line, so that would be the main difference. But when you pilot, the feeling is almost the same in both modes. So finally, we are going to demonstrate some emergency maneuver. So let's start with the hold. So I just press the hold button, which is on the drone side. And now if we zoom on the map, we can see that the drone is performing the hold pattern. So I can use my finger to move it in the middle of this field. So when we are in hold, and the drone will just perform a small circle, so you can use it as a panic button. So every time you don't know what your eBee vision is doing, you can press hold and you know it will stop where it is and perform a circle. So here I will use the fact that we are in hold to perform some emergency maneuver, but we can do them at any moment. So let's start with the fast escape. So here, let's say we want to make a fast escape. We have the compass, it shows the direction of home, the wind direction. So let's say I want to escape north. I just hold the drone control joystick up, and we see now that the eBee vision is escaping, and we are going full speed in the north direction. I can change direction in flight, and it will go full speed. And as soon as I drop the joystick, it will start to just make a hold again. So let's go again, back into the middle of our field. And now we will demonstrate another feature, which is fast climb or fast descent. So to avoid collision in flight, you can always hold the secondary control joystick down. Now we see we are in fast descent, so if we look at the altitude, it's going down pretty fast. So let's go as low as possible. And now you can see the eBee vision has stopped by itself at 60 meters above the ground, and it will wait here. I can also see it on the map. We can do the same thing just by pushing the joystick up. And if we do this, we'll see we are now in a fast climb. So if we look at the altitude, it's rising extremely fast. So that's a good way to just gain altitude fast. But always remember that this is going to make some noise, and you probably don't want to do it unless you are forced to. So that covers the main safety features that you can use to get out of trouble situation. So before we land, we can also spend a few minutes to talk about connectivity. So here we could share what I see on the screen to other members of my team by using ATAK. We can also use a HDMI cable to send the image on another screen, and like this we can share in real time the information that the pilot is seeing, which is extremely useful in operations. So now we are ready to land. So just to do this, we just need to press go land, and eBee vision is going to land. So let's go into the map view. So the landing point is displayed as an L, and if I zoom, I can see the landing parameters. So first one is a wind map, which is displaying in real time in which direction we recommend to land. And then we have the base waypoint. If we zoom further, we see the likely touchdown area. So here we want to land on the road here. So let's just put my point on the road. I will just align the descent path on the road like this, and now we are ready for landing. So now we can see the eBee vision is waiting for clearance, which means it's waiting for me to confirm that we can land. So now that everything is ready, let's just confirm. And now the eBee vision will go down. At any time, I can press abort to just cancel the landing, or I can use the drone control joystick to make slight adjustment and push it right or left. And here we got a nice demonstration of the accuracy of the eBee vision landing. So it's right on the spot. We did not miss the road, and we can go and recover the drone. So as we can see, we have the green light, so it's ready to take off again. We just turn it off with a single press. And now we can go home and see what we've filmed.
So hopefully everybody enjoyed that great demonstration that Jean-Christophe just provided. Really dove into what the platform is certainly capable of and how it can enhance definitely public safety and military or defense-oriented mission sets for sure. So in the next few slides, we're going to just kind of go into a little bit more of the flight mode detail that he kind of described, and discuss the potential use cases that they would be applicable towards. So starting with the flight plan mode that Jean-Christophe described. So this enables the user to fully prepare and configure missions in their GCS from anywhere, right? The only thing you're ever going to have to make sure that you do is have your terrain data kind of downloaded ahead of time. That's the only thing that, just kind of like the ATAK as well, just making sure that you have that terrain data downloaded for use anywhere that you're going to be operating in. This is a traditional pre-planned collection operation over a large area. It's kind of basically just for using it for initial discovery, right? Like let's maybe say you don't have some known areas of interest that you're aware of. So you're going to kind of basically go into this area and kind of do your initial discovery of the environment. This is what this would be good for. Then moving into observe mode. So observe mode allows the operator to fully focus on an area of interest, right? So I think Jean-Christophe did a great job of kind of highlighting how those points of interest can kind of be defined. And then we talked earlier about how you can also orient them based on known locations potentially. So if you have known areas of interest, you can kind of have those predefined in your flight plan after you've done some initial discovery of the environment. And a great thing that the eBee vision does once it's in observation mode is it's going to try to basically align itself to the best flight plan to collect or to be able to observe that target of interest, right? So you can also adjust that on the ground control station. So you can move left and right and kind of, back yourself off the area of interest too once you've defined it. And the eBee vision will immediately correct itself to be able to get that, the best parameters of collection while you're in observe mode. Some good use cases there, like we talked about, are if you know your areas of interest and they're already predefined, or if we're talking the public safety vertical, if we know that we potentially have an area of last known location of a potential person that's gone missing, or we're just trying to identify, kind of any activity in the area of a known location, this would be a good flight plan to apply that towards. And then scouting mode, once again, Jean-Christophe definitely gave a good overview of how this works. So let's say that, you've done your initial discovery of your environment. Okay, we've observed now some points of interest within that environment. And now let's say that we have some activity that's maybe leaving that area and we want to stay with it because it potentially can lead us to another area of discovery. Or in the public safety environment, maybe we're trying to, monitor some sort of activity going between building locations and things like that. So this would be where you would go into that flight mode to try to stay with that activity between those two locations. But certainly a lot of overlap here for public safety and defense-oriented mission sets. So the next few slides is going to talk about detection, recognition, identification capabilities. So it's just going to show kind of the eBee vision while in flight, in certain distances and things like that of what the clarity will look like. And then also too, the next three slides were basically captured simultaneously. So you can switch to this and it's very, low lapse time of between, zooming, capturing, and then having that data shareable on the ground control station. So as you can see, this is about 430 meters at 1.1 zoom. As we continue on, it's going to get a little bit closer. So, let's say we were flying, we knew this was a point of interest. We want to kind of zoom in to start to discover some, intelligence activity or potential just, any kind of activity going on in this scene. We're going to zoom in. So we're going 330 at 5.8. And this is when you would see that switch between the telephotic or the digital to, as it enhances. And then once we've defined that point of interest on that targeted area, we're going to zoom in even more. So this is now at 150 meters at 32 zoom. And you're definitely going to be able to tell any kind of associated activity in great detail that's happening in that scene. So the same thing here, this is a kind of a simultaneous shot as we are flying in thermal mode, going through from 18 millimeter all the way down to 5 digital zoom in flight at 700 meter distance in daylight. Obviously, so this is white hot and black hot, and for those maybe that not know what that means, this is going to give you the difference in temperature of an object in comparison to its ambient environment, right? So it's not going to give you the temperature of a specific object, but you're certainly going to be able to tell the difference of something that's in that environment that has a different thermal signature. Certainly enhances nighttime capability collection too for the search and rescue apparatus or operationally focused public safety people. And then for the defense-oriented stuff, I will say that most military operations, I won't say all, but certainly most take place at night. So this gives us a very reliable capability to be able to detect thermal signatures in an area that we might not have been to yet. And this is just a good slide that kind of shows what you can see and the kind of zoom and the level of detail you would be able to expect based on certain ranges and distances from those areas. And then the geographically referenced images, right? So it's very like the full picture view, and then as we zoom in, you're gathering that high level of detail. And you can use this for photogrammetry reconstruction. There's some stuff that's interoperability that we're working on that's going to be able to allow you to do some interesting things with the front end of the collection as well as to what the video can be done with afterwards or the pictures that you can gather. And then so it's moving into the interoperability piece. So as we all know, the last 20 years of defense-oriented conflict was basically a coin-operated environment. Sometimes joint operations weren't very common, but focusing on what the fight will look like going forward, it's always going to be basically a multi-domain or joint operation, right? We will never basically operate autonomously as an entity or country anymore when we're against other near-peer threats. So interoperability is obviously a huge thing that we need to focus on, and how are we going to do that? So some of the initiatives that we've done is the Department of Defense's Defense Innovation Unit to produce an eBee vision fixed drone. The GCS is part of the RAS IOP program, which is a robotic autonomous system interoperability profile. So our GCS will be, compatible with other autonomous solutions and be able to potentially control those as well. So let's say if you're a unit that's purchased the eBee Vision, but you already have some other autonomous approved programs from the DIU, you'll be able to have operational control of those platforms as well with our GCS. Video stream screen duplication, so USB-C and HDMI adapter to be able to potentially get that situational awareness in your operational command center and things like that, so we can see it. We're Nett Warrior connector and Wi-Fi or LTE. And then some of the data stuff that's compatible, ISO, IEC, and then STAGNIC 4609 compatible. All of these are just, multiple ways of how to share this data amongst multiple allies, NATO countries, and the US as well. Just being able to, it's one thing to be able to collect data, but we all know it's going to have to go somewhere and be shown to someone for it to actually become valuable or actionable intelligence. So obviously interoperability is, once again, very important for our platform to be able to perform. Now, I will say you also have the ability to operate this in a disconnected environment too, where potentially you might not have to share that intelligence. So that is, two ways of operating. So some of the configurations and antenna setups. So your short range is basically what's included, right? So if you get the eBee Vision base platform, you're going to get the short range communication setup. So that's going to give you about 5 kilometers or up to 3.1 miles of operational control. If you upgrade or need the medium range, it's going to give you that 15-kilometer operational or 9.3 miles. And then the long range extended antenna is going to give you up to that 20 kilometers or about 12.5 miles from your operational area. Now, these are all user dependent. Not every unit's going to require the medium or long. Some are just going to want the short, and it's completely adaptable to your needs or to your customers' needs for sure. And we can work with you to kind of, set up and have the questions asked of what your customer might need to see or what kind of setup they would suit them best for their operational use cases. So the slide just highlights AgEagle. So it was very important for us to position ourselves kind of in the medium range reconnaissance role, right? So there's a lot of quadcopter and short range reconnaissance aircraft out there for sure. I'm not going to say that they don't serve their purpose, and there's certainly a lot of longer range aircraft as well. We thought it was important to position ourselves kind of at the max range of shorter range, or our minimum range would be the max range of shorter or smaller aircraft, and then positioning ourselves for our max range would kind of be where your minimum range would be for a much larger or much more expensive aircraft. So what I will tell you is that being a former ISR director, ISR assets are heavily competed after, even organic ones ourselves that we have in the defense community. So enabling the tactical formations with many ISR assets as they can have is going to reduce the bandwidth needed on larger assets and letting them focus on the deeper fight. And then for the public safety vertical, just enabling some of our law enforcement or, fire oriented professionals, it's going to give them a capability that they might not have potentially had before, because it is going to be at a lower price point than some of these larger platforms. And it offers a lot of, public safety overlap features that some defense platforms just kind of don't focus on because they're so defense oriented. And I believe that takes us into our Q&A time. So please feel free to share some of your questions in our. So wind limits, it's about 10 to 13 meters per second, or roughly about 23 knots. I have confirmed that myself. I've flown in pretty high winds, and the platform does look kind of small, but it handles the wind really well. One of the use cases that we just recently sold a platform for were to support rocket launch potentially stuff, and the high wind in the area was a huge concern of theirs, and it met those requirements. Is there a real-time offboard analysis capability? So I would say that you can basically do your analysis in real time on the GCS, and then you'll have some export features as well. How can the eBee vision be transported? So that's a great question. So it comes in a backpack, and I can share some of the images with our customers at a later date with that, but you'll also be able to put that backpack in an IP67 approved transport case, otherwise known as a Pelican case. So you can, all of that system is self-contained in that unit. Have you considered designing, so the takeoff and landing, the landing is autonomous, right? So it defines your takeoff and landing area as you put the aircraft up. It is extremely accurate. Those that would be familiar with the ATAK kind of had a very, I'm not going to say it wasn't a precise landing, because it was precise, but it was a little, sometimes, wouldn't kind of land where you needed it to. The vision, I have landed in demonstrations almost right next to my leg. So it is extremely accurate, and you can define that very well with the terrain data that you've downloaded. So the satellite image that we use in the background is Mapbox. So it would be your standard 30 meter resolution. But you can also augment. So a good feature that I'd like to mention is that you could take eBee TAC data that you've flown, or you can go in Google Earth and define an area as well, and you can integrate that into the ground control station. So the sensors for the aircraft is the only one at this time for the reconnaissance. And so that's some of the interoperability stuff that we're talking about as well. So as we talk about integrating some applications on the front end of the data collection and things like that, you might be able to get some of your image analysis and image exploitation from what the system is collecting. Yes, you will get a copy of this. I think the target goal will be 24 hours after this webinar closes down. You'll be emailed the PDF and all of the video support material as well. So the auto detection capability would be the sensor operator. We don't have any AI kind of on board that would kind of determine, the human height and things like that. So it would be on the operator to define what you're looking for. Will the vision be capable of operation over people approval? 100%. That is one of AgEagle's core principles of safety, and we will We were one of the first ones in the United States to be approved for that for the ATAK, and we will be seeking that same approval as well. We do have ATAK interoperability. And you have the ability to set that in the GCS. It cannot carry any additional payloads at this time. Yeah, it does have LTE capability if you need that function. Was it a possibility? So I'm in the GIS field. I do mapping of large areas. I have an EBX and quadcopter with a vision to be able to meet the needs of mapping and surveillance. So I think one of the things that we're potentially looking at for a roadmap development would be to potentially have or enable a mapping type sensor. But for now, it is just purely full motion video. You can export the images, so can images be obtained with the flight plan and then be stitched to create orthomosaics? You can export them because they are geo-defined or geo-referenced. We have not considered landing gear. It has a carbon fiber skid plate on the bottom of it, so it was one of the improvements that we did or made from the ATAK, is gave it a larger profile on the bottom to land. As you've seen in the video with John Patrice, we've landed it on that asphalt in that area, and I've landed it on the asphalt myself several times and never had an issue. So the maximum flying altitude compared to the starting altitude, I think that's just going to be kind of your target defined, right? So if we're trying to, collect on an area where we don't want to expose noise, we're going to try to find that minimum range of where we'd like to be comfortable. But I think Jean-Christophe has put it up to 4,000 AGL to my knowledge. And its predecessor, the ATAK, I flew at 10,000 AGL. Drone's IP rating is light weather or rain, and I can confirm that as well. I did a Michigan National Guard demonstration in very heavy rain, and the aircraft performed flawlessly. So how can you prevent the body of the eBee vision being covered? So that's just a very small, you get 270-degree field of view in that belly, so it will automatically kind of adjust as in flight to be able to not capture the bottom of the aircraft. Would be able to have a demo in Sweden? Absolutely. We have a European-based sales team as well, but if it's a defense-oriented customer, I can certainly arrange that myself. Does law enforcement have the ability to legally fly drones in populated areas in the U.S.? Yes, but I know that's very state heavily dependent. Some are more applicable to let you do that than others. I would definitely check with your local law enforcement parameters there. But I know, so I just did a public safety demonstration for Florida law enforcement, and they were all about it. And the law enforcement officer I spoke to your second question was, could these be drones affixed somehow in SWAT vehicles? He had a drone kind of like locker in his police vehicle. It was an SUV, I will say that. So it was pretty cool. And he was able to just pull out that drone, and it had battery storage areas and things like that in there to be able to facilitate your usage in the field. So I would say, do you have special functions embedded into your controller? So we designed it with the ease of use, just like eMotion. So it's very, you can tactile or button operated while in flight. And it's just super simple. So one of the things that I think we need to think about in the defense-oriented landscape is the users of these are going to be between 18 to 24 years old primarily. They've been exposed to Android-based technology their entire lives, so it's going to be very familiar for them to use. How does it perform when landing on a dirt strip or adverse terrain? Very well. So I can speak to this very heavily. So its predecessor, the ATAK, I've landed in some of the most austere countries in the world, and we've improved the landing profile and the carbon fiber skid plate on the bottom, as we mentioned before. So it's certainly it does well on adverse terrain. RGB camera resolution's up to 32 zoom. So we are a drone training provider, and we'd like to train drone pilots on the eBee. We can certainly talk about that for sure. So the sound level, I would say sound profile, I would probably 250 meters off. You're not going to be able to tell or hear it. It's very quiet. It was an improved propeller design over the ATAK, so it's a little bit quieter, even though it has a more improved power plant. There are no autonomous takeoff systems planned yet. That is correct. In Central America, we also have a couple of distributors in that part of the world as well. We also have a LATAM-based sales team or salesperson, so I could certainly point you in his direction. What is your production volume capacity? That would depend on heavily, like if someone came to me tomorrow with like, hey, we need 100. We would be honest in communicating what that lead time would look like, but currently it's about 21 days. Absolutely. So for the non-defense people, and can you expand on interoperability? So interoperability so anytime we have a system and we know that we're gonna have to share that data, right? So it's gonna have to go somewhere. So much like how aircraft have the authority to operate within the DoD landscape, software is just the same way. So we need to make sure that when we have data in the government landscape, it can be put on other government networks and things like that and be shared across your government entity, if that's defense or law enforcement specific, I would imagine. Because I'm sure states and other law enforcement agencies kind of have their own IT requirements and things like that of what can be put on systems. So that was what I meant by interoperability. Just the shareability is probably the best way to describe that. General price point, so it's going to be definitely, I'll leave that to the VARs and distributors to kind of maintain, but what I will say is that we've positioned this to be very affordable and provide maximum capability over some of the much more expensive platforms. We will be seeking beyond visual line of sight, and that's one of the things I'm going to be testing with our distributors in the midsummer. The carbon skid plate is not interchangeable. I would say eBee vision applications for public safety and first responders. I know just surveillance of a potentially known area or search and rescue apparatuses, disaster response if we're trying to find people that suffered through a natural disaster type scenario. I think there's multiple uses there. Especially for rural law enforcement. This can potentially cut down your patrol area, or if you have known areas of activity in a rural area, you could put this up and kind of decrease your patrol time. That was what Florida was heavily invested in. They had some very rural areas that they just can't get to, and they put this up and kind of see what's going on. We are in the process of getting this DIU Blue UAS, just like the eBee ATAK. So this is a great question, how much of it's repairable on the location? So one of the things that not only we focus on is ease of use, is also repairability in the field. I don't think defense-oriented folks or law enforcement people probably have time to call like a technical service representative when they're having an issue. I would say almost 90% of this is repairable in the field. But there will be standard 100-hour service stuff, yeah, kind of like the EBX. We will be making our drones remote ID compliant, but I think recently the FAA extended that deadline. It did not give a new date of when that deadline would be enforced. You're not allowed to fly 250 meters in the U.S. without a waiver. I don't know if you're talking about elevation or distance, but I'm pretty sure it's 3 statute nautical miles for distance, or the RPIC has to be able to observe the aircraft unless you have a BVLOS waiver. And then for elevation profile or height, that would just be on your airspace requirements and restrictions like GE, BC, things like that. I certainly wouldn't recommend going into Class B airspace with this unless you're well coordinated ahead of time. So I really appreciate everyone's time today. And if you have any other follow-on, last one, same landing as eBee ATAK, or do you have no? So this one, it's very similar in how it will land as far as what the visual representation of the landing looks like to the eBee ATAK, but we drastically improved the GNSS landing capability, so it is much more accurate. Like when I say I have literally landed this thing next to me almost every time I've flown it, that is not an overstatement. It comes in exactly where you want it to be. And another thing too, just I'd like to speak to the landing feature there, is we have a silent tactical landing mode. So let's say you're a law enforcement or public safety in your environment, or you're in a defense environment and you need to bring this thing down quietly or potentially pass it to another unit that you have, you can trigger that and it will come down with the engine off to be able to be collected, and it will give very, you know, zero noise signature as it comes down. Yeah, it's silent tactical landing. Yeah. I really appreciate everyone's time today. And if you have any other follow-on questions, I believe my email contact is still there. Or anybody has, you know, I can answer anything or have discussions, or you want to schedule demos, we'd love to talk to you about it and let's figure it out. And I really appreciate everyone's time today. Thank you so much.